Time now to check in with the world of science with our semi-annual feature, Science A Go-Go. Despite the best efforts of the human race to destroy it, the environment seems to be putting up quite a fight. Or so say scientists who've confirmed that the hole in the ozone layer over the Antarctic has shrunken to its smallest size in 15 years. And I'm proud to say it now fits into the very same pants it wore in high school. While the hole has gotten smaller, even more significant is that it's changed shape. As you can see from the Daily Show's exclusive AccuArctic satellite, the hole is now split in two, protruding in opposite directions from the South Pole. It is believed that the shrinking in the hole represents not only an improvement for the world's climate, but the first good news ever for users of Consort hairspray for men. Back on Earth.
It's a heck of a lot of money. Thank you, Ron.
All right, check this out. These are satellite pictures from NASA back in mid-September that has now shown that the hole in the ozone layer over the Antarctic has recently split into two holes. Good news is, on your right, the two holes are smaller than the one hole on your left. So that is good news. The initial analysis says that it could be the smallest in 15 years. And of course, we need the ozone, protects us from UV light.
What does this have to do with greenhouse gases? Do we know?
It could, who knows? It could be a natural fluctuation. It could mean that maybe they've been reduced a little bit. We'll see. We'll see.
For us, just heat the foods.
And now to the stratosphere, that churning layer of air and weather between 6 and 30 miles above the Earth. The stratosphere is home to this planet's all-important ozone, which NASA now says is surprisingly in good condition. Joining us now with the lowdown on that is CNN science correspondent Ann Kellen. Now, Ann, I guess we should set this up by saying it is the ozone hole month. Is that right? How do we say it?
This is the season for the ozone layer. You know, it protects the Earth from the sun's harmful ultraviolet radiation, and if you get a sunburn, you know how that can hurt. Well, this time of the year, the end of the winter in Antarctica, for the past 20 years, there has been a seasonal thinning of this protective layer. Now, word from NASA and the National Oceanic and Atmospheric Administration is the ozone hole is smaller this year than previous years. It has not been this small since 1988, and that is good news. Now, what's unusual, it's split in two, and you're going to see this. The ozone hole is in dark blue. It started developing in August. In late September, you can actually see the hole splitting in two. NASA is blaming this on weather patterns in the upper atmosphere being so strong, so forceful, it caused it to split in two. And if you can see it, it gets close to South America, and scientists don't see that as a problem because it is smaller, and it is getting smaller even since these graphics were taken. So basically, the hole this year is 6 million square miles in the upper atmosphere, and compare that to last year's 10 million square miles. We're talking an area more or less the size of North America. That's a big hole. Now, what causes this thinning? Scientists say it's chlorine and bromine. Those are chemicals that were once used in refrigerators, air conditioners, fire suppressants. We stopped manufacturing those chemicals. They have been banned. But that's not why the ozone hole is smaller. The scientists say those chemicals are still in the air and still causing problems. The basic reason is the weather. It is warmer in the South Pole this year around that Antarctic, causing the hole to be smaller.
All right, now, Ann, let's talk about why we should care about this. Obviously, you and I know, but let's let our viewers know why this should mean something to you and me right now.
Well, Kira, you have been in Antarctica, right?
That's true. And the folks from NOAA told me at the South Pole, they actually made this prediction that the hole was getting smaller.
And so you know firsthand, though, the impact of having a hole and not. When you were there, what did you have to do?
Oh my gosh, sunscreen. I mean, in the earlobes, up the nose. We got the big lecture about sunscreen, okay? We did not mess around.
So you can tell, I mean, obviously they take this seriously. If you get a thinning of the ozone, you're losing that protection from the ultraviolet rays. So obviously they want to study this and see what it would take to close up that hole. Now, back in 1979, we have a graphic that shows year by year from 1979, there was no hole. And then every year in the 80s and the 90s, the hole gets bigger and bigger and bigger. And that is why I think there's some excitement that now we're seeing it getting smaller. But they're not saying that this is a trend. They want to watch this to see what happens in the coming years.
Wouldn't that be nice if we just didn't need sunscreen ever again, Ann?
Oh, that'll be the day.
You're
I don't
right.
think in our lifetime.
That'll be the lead story with you for about the next year.
Absolutely.
All right, Ann Kellen, thank you so much.
This today confirmed that the ozone hole over the Antarctic has shrunk over the past 2 years. The scientists also said the ozone hole has split into 2 separate holes. It's now about 6 million square miles. That compares with more than 9 million in previous years. Researchers say the decrease in the size of the ozone hole is due to this year's warmer than normal temperatures in the upper atmosphere. The scientists say they cannot definitely say the ozone layer has moved into recovery yet, however. Coming up next here, prosecutors.
Scientists report that hole in the ozone layer over the South Pole has now split in 2. Satellite imagery shows a strong, high-altitude weather pattern swirling over the Antarctic last month, and the ozone hole dividing like an amoeba. The total area of the 2 holes is now less than that of the single hole seen in recent years. What does it mean? Scientists are candid enough to admit they just aren't sure. You're watching.
Perfect song for our next segment. New data out this week suggests this year's ozone hole over the Antarctic is the second largest on record, but the news is not as bad as it might seem. Scientists say the international effort to mend the ozone hole is on track for success. Joining us now with more on that is Richard Stolarski, a research scientist with NASA's Goddard Space Flight Center and an expert on the ozone layer. Rich, thanks so much for joining us today.
Thank you. Good afternoon. It's good to be here.
Thank you. We probably should start with the bad news first. Tell us what's happening this year with the Antarctic ozone layer and how big it is, the hole.
Well, the hole is bigger than the size of North America, which has happened several times before. It is not a record, but it is very near a record. And we expect this to probably go on for as much as the next decade, depending on whether it's cold or warm in the Antarctic stratosphere.
You're the expert on this. Were you surprised?
No, I'm not surprised at all this year. The level of chlorine from chlorofluorocarbons is approximately constant now, and last year we were surprised by a very warm winter. We're not surprised if it keeps going on with fairly cold winters like this.
What created the ozone hole in the first place, and what are we going to do to fix it?
Well, what created it in the first place is ozone-destroying compounds from compounds like chlorofluorocarbons. The Montreal Protocol has been put in place. 100 and some countries have signed up to this, and we're already seeing decline in those original chlorofluorocarbons, and we're seeing a leveling off in the ozone-destroying chemicals in the stratosphere.
Is there something that each one of us can do to make a difference?
Of course, you need to protect yourself, of course, from ultraviolet rays, and I think it's basically being supportive of this type of international accords that come up in the people who are trying to make good environmental policy.
Well, I said when we started there was some bad news. Now let's get to the good news. You say the ozone hole is as big as North America. It's going to start closing up. What does that do to? How does that happen now?
Well, the chemicals that are causing the ozone depletion are slowly being removed from the atmosphere. It'll take as much as 50 years for them to be completely removed, but I would expect in the next 10 years or so to see some definite evidence that the ozone hole is starting to diminish in size.
Sounds like we're on the right track. How do you monitor the size of a hole that big?
Well, actually, we monitor it from our satellite instruments. We have a number of satellite instruments that NASA, NOAA, and also the Naval Research Lab have put into space that look down every time they pass over the Antarctic, and they measure the ultraviolet light coming back out, and you can estimate, you can measure how much ozone is there.
Well, Rich, we've heard so much over the past year or so about NASA's financial troubles. Has that affected you and your research on the ozone layer? Do you have enough money to do what you need to do?
We have been pretty much on track over quite a few decades now. I mean, everybody is feeling budget crunches these days, and things you would like to do you can't do, but pretty much it's on track to being able to continue to do this for the next 10 to 15 years. There are plans in place for a combined polar orbiting satellite series that'll start in 2010. So I think things are pretty well on track, although we can always do a better job if we have more funding.
Rich Stolarski, thank you so much for joining us today. He's a NASA scientist with NASA's Goddard Space Flight Center. Appreciate your insight. Interesting topic. And finally, we have a science story for you that's gone to the...
NASA researchers are reporting a near-record ozone hole over the South Pole this year.
At almost 11 million square miles, the hole is larger than North America. And Dr. Paul Newman, now no relation there, with NASA is here this morning to tell us about it. Good morning, Paul. Thanks for joining us.
Good morning.
So just how big is this ozone hole layer again, and what have you discovered from satellite photos about it?
Well, every year we have satellites from NASA and NOAA that measure total ozone across the entire globe. This year, as you already mentioned, it got up to nearly 11 million square miles, and that's bigger than the continent of North America. Here you can see in the middle of the image this blue rotating object. That's the ozone hole. It's bigger than the continent of Antarctica, so it's a massive loss of ozone that we see each year over Antarctica.
Now tell us, compared to last year, we know that last year was a smaller hole, one of the smallest. Why now is it so much bigger in just a year?
Well, the ozone hole is caused by the chlorine that comes from chlorofluorocarbons. We used to use chlorofluorocarbons as refrigerants and so forth. But there are variations in the temperature over Antarctica. In last year, you can see the September 2000 picture. Temperatures were quite a bit warmer, the weather was more active, and it led to a smaller ozone that split. This year, it's colder over Antarctica and less active weather-wise, and so we have a larger ozone hole. So on top of this chlorine effect, there's a temperature effect that modulates this very large loss.
And what does this mean for us, a bigger ozone hole?
Well, for this, of course, ozone screens ultraviolet radiation, and that can cause skin cancer. It can affect all biological systems. A larger ozone hole means more loss across the southern hemisphere. And of course, that's bad for the populations of South America, Australia, and New Zealand. And so we have to watch this very closely as we progress into the summertime. In the northern hemisphere, we get similar sorts of losses, but the northern hemisphere has a few things going for it. The good news is that we have higher ozone levels and temperatures don't get as cold, so we don't have as much ozone loss. But nevertheless, we do have losses, and we do have to keep a close eye on them from year to year.
Okay. Thank you, Dr. Newman, for joining us. Great information.
Thank you.
Fascinating, and I understand you make a good salad dressing, too.
Dr. Newman, you're clear. Thank you very much.
All right, thank you, Sherry. Time now is 6:46. Right now, researchers say there is a near-record ozone hole over the South Pole. What does it mean to us? Well, NASA scientist Dr. Paul Newman joins us from the Goddard Space Flight Center. Good morning, Dr. Newman. Good to have you with us this morning.
Good morning.
Okay, so last I heard, that ozone hole was actually supposed to be getting better. What's happening?
Well, this is a particularly large year. The gases that destroy ozone, they're chlorine from chlorofluorocarbons. We used to use them in as refrigerants and in spray cans. They cause the ozone hole. And they've actually been regulated and are no longer increasing, but that doesn't mean they're coming out of the atmosphere very slowly, so the ozone hole is not getting better quickly. It'll take till about 2050 before it's actually back to normal.
Okay, so why do we take a big step backwards?
Well, there's variations from year to year in the meteorology over Antarctica. Last year it was fairly active and warm over Antarctica. This year it's very inactive and cold over Antarctica. The images you see in the middle of the picture there, the dark blue color is very low ozone. You can see the difference between last year, the very large ozone hole on the left, and this year, the smaller split ozone hole on the right. So it's a difference in the meteorology between the 2 years. We have chlorine loss every year, so big ozone holes. It's just the meteorological changes that cause this year to be bigger than last year.
All right. And, you know, Doctor, for those not in the know, why should we care about the ozone layer?
Oh, ozone is the Earth's natural sunscreen. Ozone screens ultraviolet A and B radiation. UVA and UVB can cause skin cancer. They can affect all biological systems. So ozone is a critical gas for
All
life
right.
on the surface.
Gotcha. Very quickly, give me a prediction. 50 years, what are we going to see?
Well, in 50 years, it should go back to the levels that we saw when I was a child. It would go back to levels that we saw in the 70s and 80s.
Okay.
If we stick with these agreements on regulating chlorofluorocarbons and bromine compounds.
Gotcha. Dr. Paul Newman, thank you so much. Reporting live from the Goddard Space Flight Center. Love that stuff. Love listening.
You're clear. Thank you.
It really affects all of us. Yes, it does.
Well, NASA scientists are reporting a near record-sized hole, or what's actually a thinning in the ozone layer over the South Pole this year. That hole is actually larger than North America at 10.9 million square miles. Joining us live this morning from the Goddard Space Flight Center in Greenbelt, Maryland is Dr. Paul Newman. Good morning to you, Doctor.
Good morning.
We were hearing that the ozone layer was recovering, so why is this year's hole so large?
Well, every year we have ozone losses caused by chlorine gases that are primarily man-made. But the ozone hole varies from year to year because of meteorological variations that we see above Antarctica. In the middle of the screen you can see the pictures of the ozone hole. It's the big blue area that's kind of rotating around Antarctica. You can see it's much, much bigger than Antarctica. So it's these chlorine losses combined with meteorological variations that have given us, it's colder this year, over Antarctica, so we get a bigger ozone hole.
And bottom line, what does that large thinning in the ozone layer mean to those of us living here on Earth?
Well, ozone is the Earth's natural sunscreen. It prevents UVB and UVA. You see it on all the sunscreen bottles. It's the first line of defense for the Earth's surface. And so a thinning of ozone, when the ozone hole breaks up, it mixes low ozone across the southern hemisphere, and that's bad news for people who live in South America, New Zealand, Australia, and for the biological systems in the ocean also, because of increased UV levels from reduced ozone.
So is there a significant impact for those of us here in the northern hemisphere?
Well, in the northern hemisphere, of course, we have the Arctic conditions that occur every year in the spring, and we have seen significant thinning of the ozone layer above the Arctic. And again, that's changed. If it's a cold year over the Arctic, we get more ozone loss. A warm year gives us a little bit less. 1997, the years 2000, were fairly bad years for ozone over the Arctic. And so we worry a lot about monitoring the ozone layer and understanding what causes these changes.
And I know we don't have a whole lot of time left, but quickly, your projections over the next few decades as far as the ozone is concerned?
Yeah, the gases that destroy ozone, chlorofluorocarbons, were regulated. In fact, we stopped production in the U.S. in 1995. So we're predicting that things will recover by about the year 2050. So it's a good news, bad news situation. Right now, we have large losses, but it'll be getting better as we go out to about 2050 and should be back to normal in 2050.
All right, I'll look forward to that when I'm 80. Thank you. Dr. Paul Newman, appreciate you joining us this morning.
Bye.
All right. Thanks, Micah. Well, a bit later, some amazing breakthroughs in